Hi guys, for today's video we're going to be dealing with solving simultaneous equations graphically. So in the past we've dealt with simultaneous equations, but we've always solved them algebraically. We can also solve them graphically. So first word to understand is the point of intersection. So it's the point where two lines meet. It's where they intersect, where they hit each other. So for example, the lines y equals 2x and y equals negative half x minus 4, they intersect at the point negative 2, negative 4. And we can see that when we graph these two lines. So negative y equals 2x is graphed right there. And y equals negative half x minus 4 is that green line there, and they intersect at this point, and that point is the point minus 2 minus 4. So that's what I mean by a point of intersection. So some rules to remember when you're doing this is that we can solve a pair of simultaneous equations using a graphical method. So step one is to graph both equations on the same number plane. And then step two, the point of intersection's coordinates give the solution to x and y. So in simultaneous equations, we always need to figure out what y equals and what x equals. And we can find out that from the coordinates of this point of intersection. So for example, like the solution to these two simultaneous equations would be x equals negative 2 and y equals negative 4, because x always is the first value is like your x coordinate. Okay, so some example questions. So solve the following pairs of simultaneous equations graphically. So I give you these two equations. These are quite easy to graph because they're in gradient intercept form. Our y is the subject for both. So you can see the gradients for both lines in front of as our coefficient for x, and we can see our y-intercepts as the constants. Okay, so step one, we need to graph both of these equations on the same number plane. So we'll do the purple one first, y equals 4x minus 2. You can see here our gradient's 4. So that means our rise and run is going to be 4 over 1, because that's what 4 is equal to. And you can see there that we make sure that it's positive gradients going uphill. And you can start from this y-intercept of negative 2 down here. And pretty much make the correct triangle from that point. With the blue line, y equals negative 3x plus 5. The y-intercept is the positive 5, and we needed to make a triangle for negative 3. That's going to be going downhill. So you can see that our line goes downhill, and we needed to make a gradient of 3 over 1. So you can see here the rise is 3 and the run is 1. So that's the correct triangle for that point. For the line. And so you pretty much graph both of these lines. And step number 2 is you then look at the point of intersection of these lines. So this point here has the coordinates 1, 2. So therefore, our answer to our simultaneous equation is that x is 1 and y is 2, as you can see here. Simple as that. Let's try a bit of a trickier one. So I give you two equations here, but notice that they're not in gradient intercept form. So the easiest way to graph these lines is to change them up so they they are in gradient intercept form and then graph them. So this is what I've done first here. So I got y as my subject. I moved the 3x over, and then I divided by negative 2 to get y by itself. So we've got 4 minus 3x all divided by 2. So 4 divided by minus 2, that gives me a y-intercept of negative 2. That's the constant. And negative 3x divided by negative 2, that gives me positive 3 over 2 lots of x. So my gradient is 3 over 2 for that one. This one here, I just fixed this up. This one is a little bit easier. Because all we need to do is minus the 3 from both sides to get our y as the subject. And looking at this, x plus 3, our y-intercept is 3, and our gradient is 1, because that's the coefficient of x. Okay, so let's graph both of these equations. So we've got y equals x plus 3, and this one here as well. Now, when I graph these on a small number plane like this, you can see this is a gradient of 1. So that's going to be a rise and run of 1 each. And this one down here has a rise and run of 3 and 2. So there's my rise of 3 and my run of 2. So I've graphed both of them, but they haven't intersected each other. There's no point of intersection. So the graph isn't big enough to show the point of intersection. So I'm actually going to kind of zoom in on this first quadrant here. So I made this first quadrant a lot bigger, as you can see over here. And eventually they did intersect. The way that I continued to graph this line was to just keep the rise and run going to pretty much make sure I did a really good graph. So it was always going 2, 3, 2, 3, 2, 3 because that was the gradient. And the gradient for 1 was just 1, 1, 1, 1, 1, 1. And eventually we get to this point of intersection here, which is the point 10, 13. So therefore, the answer to my simultaneous equations is x equals 10 and y equals 13. Hope this helps with the questions. Good luck, guys.